Welcome to the session of thermodynamics. Today we will discuss about the topic that is thermodynamic cycles. Okay. So first of all, it is clear to us what actually this thermodynamics deals with. So what is cycle basically? Cycle is basically a relation by which you can relate science and technology. Okay. That if you utilize this science in daily life for a continuous span, then you can use this cycle as an agent. Okay. So this cycle, if you use this science in a cycle, then you will have a continuous technology that is developed and that will basically benefit the humankind. Okay. So you can classify cycle based on various way. Before coming on to it, we should know that this science is basically with the help of cycles we can develop into technology. Okay. And this thermodynamics has two broad fields in which it is applied. One is for power generation, another is for refrigeration effect or heating effect. Okay. These are the two broad fields in which this thermodynamics in today's world is popular. One is for power generation, another is for refrigeration effect. Okay. Okay. Another very important thing is that we will classify cycle on based on certain parameters. Okay. The parameters upon which we can classify a thermodynamic cycle is basically based on usage. Okay. That whether we are using the cycle for generation of power or we are using it as an refrigeration effect or heating purpose. Okay. So under power we can have basically two classification more. Okay. The power cycle classified into two things. One is maybe external combustion, maybe internal combustion. Okay. Another thing is third one, that is open or closed cycle. And the fourth one is for single component or multiple component, more than one. That is, and the last one of the most important, is basically depending on the working fluid that we are basically using for a cycle. And we will discuss each of one. Okay. So first of all, what we are coming is basically the power cycle. Okay. So what do you mean by power cycle? Okay. In the power cycle, we are using a heat engine. Okay. We are using a heat engine that is basically taking heat from one temperature reservoir, and rejecting heat to another temperature reservoir, producing a work to the surrounding. The objective of the heat engine is to produce work to the surrounding. Okay, and that is the output what we are getting. Okay, so here the T1 is greater than T2. Okay, because the heat engine is extracting heat from high temperature body and rejecting heat to low temperature body. By Kelvin-Planck statement, this Q2 cannot be 0. Okay. Okay. And this is basically the thermal reservoir and this is the thermal sink. Okay. Another thing, this power cycle basically operates in a clockwise fashion. Okay. And this heat engine is not basically a single component device. It is, if you consider it as a system, and it is consisting of different components. For four fundamental components are boiler, turbine, condenser, and a pump. Okay. So this heat engine is a system consisting of different components, and this cycles that operates within the components that occur in a clockwise fashion. Okay. And the objective of this one is basically to produce work. Okay. And this power cycle is clockwise. Means power cycle operates in clockwise manner. Okay. Another thing, that is the refrigeration cycle or a heat pump cycle. Okay. So we have an refrigerator or a heat pump that will take heat from low temperature body, suppose T1, and reject heat to some high temperature body. We all know that spontaneously heat cannot flow from low temperature body to high temperature body. Okay? With the help of a refrigerator or a heat pump, we can take heat from a low temperature body and deliver it to high temperature body as guided by Clausius statement. Okay? And that is only possible if it takes some work from the surrounding. Okay? As guided by the Clausius statement, is W that is needed by this heat pump to deliver heat from low temperature body to high temperature body cannot be 0. Okay, this W cannot be 0. Okay, so another thing what we are getting, that this objective of a refrigerator is to maintain the temperature of this refrigerator space. Okay, and if we use this cycle as a heat pump cycle, then the objective will be that how much heating is, or how much heat we are delivering to this temperature reservoir, that is T2. Okay, so basically this cycle, refrigeration cycle or heat pump cycle, operates in a anti-clockwise fashion. Okay, so basically power cycle is clockwise in nature, and this refrigeration cycle or heat pump cycle operates in anti-clockwise fashion. Okay, so now we are further classifying this power cycle. Okay, where the power generation is there, that if we want to run a power cycle, we need energy, and that energy can be classified in two ways. That energy that we get maybe by two ways. One is by external combustion, maybe by internal combustion. So what is basically external combustion? That is, the heat is evolved. Heat is evolved outside the working fluid. What does it mean? That is, the heat is transferred through the physical boundary, that is the wall of the boiler or maybe the condenser, into the working fluid. Okay, and the combustion process is generally works outside the working fluid. Okay, that is, and another important thing, that is the composition of working fluid remains same. Okay, as per concern for the external combustion, we are getting the heat is evolved outside the working fluid and the composition remains same. Okay, but in case of an internal combustion, this combustion takes place within the working fluid. Okay, and by this process a very high temperature can be achieved. Okay, and the composition can change. Okay, example of internal combustion cycles, basically the diesel engine cycle or petrol engine cycle, or for an example of an external combustion process for generating power is basically steam power plant. Here is basically diesel cycle or petrol cycle. Okay, so this power cycle can be further classified into two, that is external combustion and internal combustion, where in case of an external combustion, what occurs, that heat evolved outside the working fluid, where the composition of the working fluid changes. Okay, an example of it is steam power plant, and in case of an internal combustion, the heat is evolved within the working fluid. Okay, and the composition may change, and that is example of it is basically diesel engine cycle and petrol engine cycle. Okay, so another way by which we can classify cycle is basically open cycle or closed cycle. What is open cycle? At least one process takes place outside the plant and it depends on nature. Okay, the example of it may be that a petrol engine, okay, where it takes fresh air from outside ambient condition and expel the exhaust or the combustion product to the atmosphere, and it is basically connected. This cycle is basically connected by the nature. Okay, so this is basically an open cycle where the one process at least takes outside the plant, and it depends on the nature. Okay, and this basically becomes a connection for a cycle because the amount of fresh air which is basically getting into the petrol engine and the exhaust product from the petrol engine is basically connected by the nature. Okay, another thing is basically the closed cycle, that all processes occur within the plant. Example, there is steam power plant. We have a boiler, we have a turbine, we have a condenser, we have a pump, and all the process that are occurring within the heat engine cycle. Okay, so there is no process that occurring outside the plant. Okay, so in this way we can classify the cycles on the basis of what are the number of processes that can occur within the cycle or the process which occurs outside the cycle. Okay. Another way by which we can classify is basically the single component or a multi-component. What is a single component one? That in a cycle, when it occurs within a one system, that is a piston cylinder. Okay, in case of a single component, where all the process takes place in that single cylinder. Okay, and that is basically a single component cycle. That is example of it basically the petrol cycle or diesel cycle. Okay, another way is basically a multi-component cycle, that all the process takes place in separate components. Okay, so basically if you are thinking of a steam power plant, okay, so there are various components that are used. One is boiler, one is turbine, one is condenser. So it has more than one component which has various purpose for each of the one. That is, boiler is basically a heat exchanger, and turbine is basically a work producing device. Okay, so basically it has more than one component that we are using it for all the processes. Okay, so example of it is steam power plants. Okay, so another way by which we can classify the cycles, thermodynamic cycles, is basically on the basis of working fluid. Okay, one may be gas cycle, one may be vapor cycle. In case of a gas cycle, what happens? No phase change occurs during the whole process. There is no phase change. Okay, but in case of vapor cycle, phase change occurs. Okay, in different processes that occurs within the cycle, there are different phases with which it operates. Okay, phase change of phase occurs. Okay, another one is basically in case of a gas cycle, standard analyses are there to set the performance parameters. Okay, that means there are certain assumptions that we have to take for analyzing it. Okay, in case of a vapor cycle, there is no standard analysis. Okay, no standard analysis. Here basically we need a standard analysis to set the performance parameter. Okay, another is basically that in case of a vapor cycle, basically the equation of state what we will get is not simple. Okay, that will be simple for gas cycle. So the example of gas cycle is basically the petrol engine cycle, and the example of vapor cycle is basically steam power plant. Okay, so basically these are the two examples. For gas cycle is basically petrol engine or diesel engine, and in case of vapor cycle what we are getting is basically the steam power plant. Okay, Now, if you want to analyze a steam power plant, on the basis of which what we analyzed, the different types of cycles that we classified, on the basis of that, if you want to investigate or study the steam power plant, on what basis you will analyze. That is basically, first of all, will be the power cycle. It will be a power cycle because the objective of steam power plant is to produce power. On the other hand, is basically it is an external combustion process. Okay, that the heat that basically evolved to the working fluid or basically given to the working fluid is by external combustion. Okay, another is that is a closed cycle. That is all the processes occurs within the plant. Okay, another is that there are more than one component that are used in a steam power plant: boiler, turbine, condenser. Okay, so it's a multi-component cycle. Okay, and at last, the working fluid that we are using is vapor, that is having more than one phases. Okay, that is steam that we are using for a steam power plant. Okay, same thing can be done for an household refrigeration, where we are using the refrigeration, that we are classifying cycle with respect to usage, that is for refrigeration. Okay, and this classification of power is not there in case of household refrigeration. Only thing that will be, it is whether it's closed or it is open. It is a closed one because all the process occurs within the cycle, okay, or within the system. Okay, and now another thing is that it's consisting of more than one component. So it is a multi-component cycle. And on the other hand, the working fluid that we are using may be vapor, maybe gas. Okay, maybe vapor, maybe gas. It is depending on the conditions. Okay, so these are the two cycles what we are analyzing it, and you can further analyze for turbojet engines and gas turbine power plant also. Okay, and this there are different ways by which you can classify these thermodynamic cycles, and it is very important for analyzing thermodynamics on the basis of cycles. Okay, thank you.